Right now, you're probably thinking about every time you've looked up at the night sky and seen those magical streaks of light racing across the darkness. You've made wishes on them, pointed them out to friends, and called them shooting stars your entire life. It's one of the most romantic and mysterious sights in the night sky, and the name makes perfect sense. They look like stars shooting across space, but here's the absolutely mind-blowing truth that's going to shatter everything you think you know about those beautiful lights in the sky. Shooting stars aren't stars at all. Not even close. They're not even in space when you see them. They're actually tiny pieces of cosmic debris burning up in Earth's atmosphere, most of them no bigger than grains of sand. I know this sounds completely impossible. We've been calling them shooting stars for thousands of years. The name is so deeply ingrained in human culture that it feels like questioning gravity itself. But stick with me for the next few minutes because this is going to completely blow your mind and change how you see those magical streaks of light forever. Let's start with what's actually creating those incredible light shows above your head, and prepare to have your mind absolutely destroyed by the reality of what you're witnessing. Those shooting stars are actually meteors, tiny fragments of asteroids, comets, and other space debris that slam into Earth's atmosphere at absolutely incredible speeds. We're talking about velocities between 25,000 and 160,000 miles per hour. That's fast enough to travel from New York to Los Angeles in about 2 minutes. Here's where it gets mind-blowing. When these cosmic particles hit our atmosphere at these insane speeds, the friction creates temperatures of over 3,000 degrees Fahrenheit, hot enough to vaporize steel instantly. The particle doesn't just burn up, it literally gets torn apart at the atomic level, creating that brilliant streak of light you see racing across the sky. But here's what'll really mess with your head about the scale we're dealing with. Most shooting stars are created by particles smaller than a pea. Some are as tiny as grains of sand or even specks of dust. Yet these microscopic pieces of cosmic debris create light shows so bright you can see them from hundreds of miles away. Think about that for a second. A piece of space dust smaller than what you'd brush off your shirt is traveling so fast and burning so hot that it lights up the entire sky like a cosmic firework. That's the incredible power of physics at extreme speeds. The reason we call them shooting stars is purely because of how they look to our eyes. Ancient civilizations saw these streaks of light and naturally assumed they were stars falling from the heavens or racing across the sky. They had no way of knowing these lights were actually happening in Earth's atmosphere, much closer than any actual star. Real stars are massive balls of nuclear fusion burning billions of miles away. The closest star to Earth besides our Sun is over 4 light years away. That's about 24 trillion miles. Stars don't shoot anywhere. They're basically stationary from our perspective, slowly burning through their nuclear fuel over millions or billions of years. But here's where the story gets absolutely incredible. Those tiny particles creating shooting stars are actually cosmic messengers carrying information about the formation of our solar system. When a comet travels close to the sun, the heat causes ice and rock to vaporize and break off, creating a trail of debris along the comet's orbit. When Earth passes through one of these debris trails, we get meteor showers, organized cosmic light shows where you can see dozens or even hundreds of shooting stars per hour, all appearing to radiate from the same point in the sky. It's like the universe is putting on a fireworks display just for us. The most famous meteor shower is the Perseids. In August, created by debris from comet Swift-Tuttle. During peak nights, you can see up to 100 meteors per hour. That's more than one shooting star every minute, all caused by tiny fragments of a comet that passed by over 130 years ago. Here's something that'll blow your mind about meteor timing. The Geminids meteor shower in December is actually caused by debris from an asteroid called 3200 Phaethon. Scientists think this asteroid might be a dead comet that lost all its ice and is now just a rocky core still shedding dust particles, but here's where it gets really wild about the science of why meteors glow. The light you see isn't just from the particle burning up, it's also from the air molecules getting excited by the incredible heat and energy. Oxygen glows green and red, nitrogen glows blue and purple, and sodium glows yellow. Different meteors can create different colored streaks depending on their composition and the atmospheric conditions. Some meteors are so bright they're called fireballs or bolides. These spectacular events can light up the entire landscape like daylight for a few seconds and are usually caused by larger particles, maybe the size of a marble or golf ball. The most extreme fireballs can even create sonic booms that people hear on the ground. Here's what's absolutely incredible about meteor speeds and physics. These particles are moving so fast that they compress the air in front of them, creating a shock wave that heats the air to plasma temperatures. The meteor isn't just burning up from friction, it's literally creating a small artificial aurora around itself as it screams through the atmosphere. Most meteors burn up completely between 50 and 75 miles above Earth's surface. That's in the mesosphere, the part of our atmosphere where the air is thin enough that these cosmic particles can penetrate, but thick enough to create the friction that destroys them. But here's where it gets really fascinating: not all meteors burn up completely. The larger ones that survive the journey through our atmosphere and hit the ground are called meteorites. These cosmic rocks are incredibly valuable to scientists because they're basically free samples of asteroids and comets delivered right to our doorstep. The difference between meteoroids, meteors, and meteorites is going to blow your mind with how precise scientists have to be. A meteoroid is the object floating in space. A meteor is the light phenomenon you see when it burns up in the atmosphere. A meteorite is the piece that survives and hits the ground. Same object, different names depending on where it is in its journey. Here's something absolutely incredible about meteor composition. Most meteors come from asteroids and are made of rock and metal, iron, nickel, and various stone materials. But some come from comets and contain organic compounds, water, ice, and complex carbon molecules. These cosmic particles might have helped deliver the building blocks of life to early Earth. Scientists have even identified meteorites that came from Mars and the Moon, blasted off those worlds by massive asteroid impacts millions of years ago. So, when you see a shooting star, you might be watching a piece of another planet burning up in our atmosphere. The speed of meteors also depends on their direction relative to Earth's orbit. Earth is traveling around the Sun at about 67,000 miles per hour. Meteors that hit us head-on can have combined speeds of over 160,000 miles per hour, while ones that catch up to us from behind move much slower relative to our atmosphere. Here's what's really wild about meteor frequency. Scientists estimate that about 25 million meteors enter Earth's atmosphere every single day. Most are too small or happen during daylight when you can't see them, but the cosmic bombardment is constant. We're literally living inside a cosmic shooting gallery. But here's the beautiful part about meteor watching. Unlike real stars, shooting stars are completely unpredictable. You never know when one will streak across your field of view. Real stars follow predictable patterns and positions, but meteors are cosmic surprises that keep the night sky exciting and magical. The atmosphere that creates shooting stars also protects us from this constant cosmic bombardment. Without our atmospheric shield, Earth's surface would be constantly pelted by these high-speed particles like the Moon, which is covered in impact craters from billions of years of meteor strikes. Here's something that'll mess with your head about space exploration. When astronauts are outside Earth's protective atmosphere, they're vulnerable to the same cosmic debris that creates shooting stars. Space stations and spacecraft have to be designed to withstand impacts from tiny particles traveling at meteor Speeds. The International Space Station actually has to perform debris avoidance maneuvers when larger pieces of space junk are detected heading their way. What's beautiful and harmless from the ground becomes a serious safety concern once you leave our atmospheric protection. Ancient cultures around the world developed myths and legends about shooting stars, often seeing them as messages from gods or spirits of the departed traveling to the afterlife. The wish-making tradition probably comes from the idea that these celestial messengers could carry your desires to the heavens, but here's the incredible irony. While shooting stars aren't actually stars, they connect us to the cosmos in an even more intimate way. Every meteor you see is a physical piece of our solar system visiting Earth, a tangible connection to the asteroid belt, comets, and the cosmic processes that formed our world. The fact that we can see individual particles from space burning up in real time is actually more amazing than if they were distant stars. You're witnessing the final moments of cosmic travelers that have been floating through space for millions or billions of years.